Hello, in this tutorial I am going to explain this ball bending schedule sheet to you. Before creating the ball bending schedule, as we are going to create the ball bending schedule here in this sheet, it is very important to explain this sheet to you if you are beginner, okay? So let's get started. We are going to create the ball bending schedule right now in MKS system in meter and the millimeter. So this is the sheet according to those units, okay? So first of all, the first column over here is for serial number, okay? 1, 2, 3. Then we need to give here the members. Members could be slab, could be beam, could be column, okay, retaining wall, it could be anything, okay? So you need to mention over here what the member. Next one, then we need to give the size of that particular member, length, breadth and the height, important, okay? Then next to it we need to give here the bar detail. Bar detail mean whether it is main bar, it is distribution bar, it is longitudinal bar, dowel bar, stirrups, okay? You need to give here the particular placing of the bar, okay? So hope you understand up to this position. Then next to it we need to give here the spacing of bar, okay? Let's suppose you are finding the main bar, so between two main bars, what is the spacing? It will be mentioned on the drawing. You need to put it over here, the spacing, okay? Center distance. Or if you are finding the stirrups, you need to give the distance between two stirrups, will be mentioned on the drawing. Next to it we need to create the shape, and I'll let you know about how we can create the shape over here, okay, in the detail. But here for now you have to understand that we need to create the shape for that particular bar. Let's suppose we are finding the main bar, we need to create the shape according to drawing, okay? Next to it we have bend directions as well, okay? So we have different bends over here, 45 degree, 90 degree, 135 degree, 180 degree, okay? So according to your need you can put the values over here, okay? If you have to find out the bend directions for 120 degree, you can put the value over here. Right now I have just mentioned only 45 degree, 90 degree, 135 degree and 180 degree. So we can deduct the bend here in these cells, okay? Next to it we have the next column as bend or the development length. We can give here the hook length, development length, okay, bend length over here, okay? Next to it we have to put here the dia of that particular bar, okay, in millimeter, okay? Bend will be also in millimeter, okay? And concrete cover also we need to put it in the millimeter. Then we need to find out the number of bars. So let's suppose you are finding main bars, okay, and the total span is 2000 millimeter, mean 2 meter, okay? Let me just give you the example over here. Let's suppose you are finding the main bar and total span is 2000, okay? Let's suppose the span is length over here, 2000 is the span, 2000 in millimeter, and spacing that you are using over here is 300 center to center, okay? 300 center to center, so 300 millimeter center to center. You can check this formatting as well. I'll just let you know about how we can do the format over here. Like I have put here the value as 300. You can see the 300 millimeter center center, okay, with this. So you're finding what the number of bars. So number of bars will be equal to this span divided by, we have spacing over here, plus 1. So this is basically 7.66, and if you will round off this, you will round up this one, we need what, total of 8 bars, okay? So this is basically number of bars. Then you need to give here number of members, okay? Let's suppose you are finding the ball bending schedule for foundation 1, and you are finding what the main bars for that particular, and the same foundations we have 3 numbers, okay? You have foundation 1 as 3 numbers, okay? So you will give here the number as 3 numbers, okay? You have same foundation in 3 different locations, okay? So in order to find out for all of those 3, you will put here the members as 3, okay? And you will find out the first 1 multiplied by 3 will give you the all of those values, and total numbers definitely will be equal to number of bars multiplied by number of members. And next to it we need to find out the total length, and total length will be equal to cut length multiplied by total numbers. So cut length, when we will create the shape, we will find out the cut length over here. So cut length, and then we need to definitely do the bend directions, okay? If we have any kind of hook length over here, we need to add that particular over here, multiply by total numbers will give us the total length over here, okay? So hope you understand up to this position. Next to it we have total length over here. total length for 6 mm, total length for 8 mm, and total length for 10 mm, 12 mm, and if even in your case you have 16 mm, okay, or it could be any die, you can put it over here, okay. Now let me just give you the example over here. What is the benefit of this 6 mm, 8 mm, 10 mm, 12 mm, okay. Let's suppose here we are going to find out what the total numbers, okay, the total length over here for the bars. In order to find out this one, definitely first of all we need to find out what are the total numbers, okay. Let's take an example. We have total numbers of foundation. Let's suppose we are finding the foundation. We have only one foundation, and in order to find out the total numbers, it will be equal to number of bars multiplied by number of members, okay. So we have some around 8 bars over here, okay. Now to find out total length, first of all we need to find out the cut length of bar. Let's suppose, let me just create the bar shape over here. This is straightforward shape over here, okay, and length of this bar is 1200 mm, okay, 1200 mm. Now in order to find out total length, what we will do is equal to cut length multiplied by total numbers, okay, cut length multiplied by total numbers. And if you need to convert it into meter, start this one, okay, and divide it on 1000 in order to convert it into meter. Hit enter. So this is what the total requirement, this is what the total length we need, okay. Up to this is same, but when we will put the dia over here, okay, when we will put the dia, you can see the result over here, okay. Right now I'll put the dia as the dia of this bar. Let's suppose we have 6 mm bar we are using. Hit enter. Now you can see automatically this value has been added over here under 6 mm column, okay. Let's suppose dia is 8 mm, 8, hit enter. Now it is just jumped under 8 mm. Let's suppose it is 10 mm, hit enter. Now it is under 10 mm, 12 mm, it is under 12 mm. So this is basically the benefit of this one, okay. Where the dia is 6, 8, 10, you need to put the dia over here. According to this dia, it will jump the values over here, okay, under concern column, okay. So this is basically the benefit. And why this is happening over here? Because of this formula. We have put one formula, okay, the logical formula over here. We have given the condition over here, okay, and you can see the condition. Condition is basically if R4 is equal to 6, okay, R basically this one, this cell is equal to 6. So let me just put 6 over here, okay. So if this cell is equal to 6, then take the value of Y4, okay, the total length. But another condition is over here. If this cell is not greater than 6, then take this value, okay. So both of these conditions are very important. Now in next cell we have changed the value. If R4 is equal to 8, if this cell is equal to 8, then put all of the data here in this cell. If this cell is equal to 10, then put all of this data here in this cell, okay. So when we will change the dia, according to this dia, values will be move under concern column, okay. So this is basically the time saving, okay. So hope you understand the formula over here. Now next to it, at the bottom we have total length over here. So what we will do, we will use here the sum formula in order to find out the total length under 6 mm, 8 mm, 10 mm and 12 mm. Then unit weight in kg, as I have already explained in B.B.S basic, okay, how we can find out the unit weight. So it is equal to d square, okay, dia square divided by 162.162 in millimeter, okay. So we have used here the formula d square, 6 into 6, okay, this cell into this cell divided by 162.162. Same goes for this one as well, same this for, okay, same for this, okay. And total weight will be equal to what? Total length multiplied by unit weight, okay, for this one as well, for this one as well, for this one as well. And total weight in ton, all we need to do is we need to divide it on 1000 in order to convert kg into ton, okay. So this one, this one, this one and this one. So this is basically the B.B.S sheet, and this is very important to understand this sheet before creating the B.B.S. Now one important thing is basically this formatting, okay, formatting. You can see I'm going to select this cell, and here it is 6 mm, and here in the formula bar I can see this is only 6, okay. Here it is 8 mm, but here it is only 8. So I have done some of the formatting over here, okay, and this formatting is very important. Let's pause. Why this formatting is important? Here we are going to find out the number of bars, okay, so it is equal to what? Span divided by spacing plus 1, and spacing is 300 millimeter center. It is mentioned over here 300 millimeter center to center, okay. So when I will do what? When I'll put here any of the value, automatically this formatting will be over here millimeter center to center. So what is benefit of this? When we will add the formula, it will not give any kind of error. But if we do without this formatting, okay, without this formatting, what will be happen? Let's suppose this is our spacing cell, okay. I'm going to give here the spacing as 200, okay, and then millimeter, okay, center to center, center to center. This is without formatting, okay. So this is what we have, the spacing 200 millimeters center to center. I'm going to find out the total number of bars over here. So let's suppose we have total span as 1200, okay. So total number of bars I'm going to find out over here, equal to this is span divided by this is spacing plus 1 will give us the total number of bars. And you can see the hash value, because we do not have any kind of formatting, and we have center we have right here, okay, without any formatting. So this is very important to just learn how we can do this kind of formatting over here, okay, whether it is over here or it is over here, okay, because it is also very important over here as well. What we have done over here is, in order to find out the unit weight, we have done 6 into 6 divided by this cell into this cell. If we will have not formatting, it will give the hash value over here. So in next tutorial we will see how we can do this formatting over here. Hope you really understand this session. I'll see you in the next.